Okay, hello students. In these sessions, we will learn something called constructor and destructors. They are special type of member functions in class. So let's learn about them. So first, what is constructor? We have already talked about functions, and we learned that the functions in the class are member functions. And the constructor is also member functions, but it is a special types of member functions. It has different function signature compared to other ordinary member functions, and it cannot be invoked as ordinary member functions, and it has different purposes. Constructor is automatically called when you create objects from class. So it's automatically called. And because it is called very beginning of object creations, the main purpose of the constructor is initializing objects. And because it is always automatically called when object is being created, the constructor is very good place where you initialize member variables of the objects. And because they are called automatically, in general, you cannot call constructor explicitly. And because constructor is also member functions, you can define constructor just like other member functions in your class definitions. But the name of the constructor must be same as the class name, and the constructor does not return any value, not even void type. So you cannot declare the return type of the constructor. These two are the main differences between constructor and other ordinary functions. Let's look at this example code. Here we have class definitions. The name of the class is day of year. And as you can see here, we can declare, we declared one member functions and two member variables. It has and the member function has the same name as the class name, and it does not have a return type. So this is a constructor. And note that the constructor is placed in public sessions of the class. In general, you should make the constructor public. If you make the constructor private, you cannot create object of that class. I will come back to the private constructor in the later slide. We saw the declaration of the constructor. Now let's look at the definition of the constructors. Definition of the constructor is nothing special. The constructor can be defined in the same way as we do for ordinary member functions. As you can see from this example code, we put the name of the class where this constructor belongs to, and then the scope resolution operator, and then the constructor name, which should be same as the class name. But note that there is no return type because constructor does not return any value. Other part of the constructor definition is same as ordinary member functions. We put the logic of the constructor inside of these open and close brackets. Note that I said that the main purpose of the constructor is to initialize member variable of the objects. So here, this constructor initializes the member variable month and day inside of this constructor body. There is an alternative way of defining constructors. The previous definition, we initialize member variable inside of the constructor. So we initialize month and day member variable inside of this constructor body. But you can initialize month and day member variable like this way. Oops, sorry. The column followed by a list of some or all the member variables separate by the comma. In each member variable, we place the value between open and closed brackets, which will be used to initialize the member variable. So this, the month member variable will be set to the value of month value arguments. The value of day value arguments will be used to initialize the member variable day. So like shown in this example, we can take out the statements for initializing member variable outside of the constructor body. And this line, the red line, is called the initialization sections. Since we can initialize member variables inside of the constructor body, what is the advantage of using these initialization sections? First, the initialization section is a good place to set default value for each member variables. And using initialization sections, we can make the shorter version of the constructor body. For example, we can initialize member variable in the initialization sections, and we can put some validation code, validations of the argument inside of this constructor body. So we can separate initialize statements and the validation code. Another reason for using initialization section is that we could initialize const or reference member variables in the initialization sections. They cannot be initialized inside of the constructor body. They can only be initialized in the initialization sections. So these are the reasons for using initialization sections. Can we still use initialization sections if argument name is same as the member variable name? Let's check it with a demo code. So let me first run this program. So if I run this program produces this output. First of all, as you can see here, there's a class definitions. This class name is a day of year, and this is a constructor, and it has a 2 member variable, and it has a 1 member function output. And here we have a constructor definitions, and we use a initialization section to initialize the member variable month and day. And it print the argument value here. This is the definitions of output member function. It just prints the member variable month and day. And in the main function, we declare the class variable Christmas and pass 2 value 12 and 25. And we call the output member functions. So when we declare the class variable like this, the constructor which takes 2 arguments will be called automatically by the compiler. I will talk about this one soon in the later slides. So just for now, just know that if we declare the class variable like this constructor will be called automatically by the compiler. And because we passed the 12 and 25 for the argument to this constructor, the months will be set to 12 and day will be set to 25. So here, because we print the 12 months value and the day values, it prints in the constructor day of year is 12, comma, and 25. And because months and day are set with these two arguments, 12 and 25, when we call these output member functions to print member variable months and day member variable, it prints months 12, day 25, like this. So what was our last question? Can we still use, so one before going to that one. So this is an initialization section we just talked about. Column and put the member variables here, separate by the comma. So you can initialize the member variable inside of this initialization sections or inside of the constructor body like this. So the question was that whether we can still use these initialization sections if the argument name is same as the member variable name. So let's check that one. So as you can see here, I changed the constructor so that the argument name is same as the member variable name. So months is the arguments and this month is a member variable. Let's compile this code. As you can see here, the program still works even the argument name and the member variable name is same. We can still use the initialization section for initializing the member variable. Even the argument name is the same as the member variable name. So this program produces this output. This output comes from here, and this one here, and this one comes here. So this indicates the current object. So this one prints the value of the member variable. This one prints the argument value, this one. So we can differentiate between the member variable months and the argument months. So because they both have a 12, because we set the member variable to 12 here. So this one both stores the 12 value at this point. So that is the reason why this program produced 12 and 12. And the last line, this one is printed because of we call the output member function. So the last line is printed here. We just print the member variable months and day, which is 12 and 25 because we initialized months 12 and day 25 in this constructor. So the answer, whether we can still use the initialization sections even the argument name and the member variable name is same, is yes. And you can use the initialization section for setting the default value for the member variable like this. So here we use the initialization sections and setting the default value for the member variable months is 12 and member variable day is 5. And we can use we can set the member variable like this one. So because we are setting only the months member variable to this argument, the day member variable will be set to the default value, which is a 5. So you can use this initialization for the default value. Okay, let's go back to the slides. Okay, we just talked about the initialization sections. This was the demo code we just have. Look at it. Now let's study about how to call the constructor. If you look at this example, we are declaring two objects of day of year class, date 1 and date 2. And while we are declaring the objects, we put some values between open and close brackets, like this. The constructor, because we passed the two values, the constructor which receives two arguments will be automatically called if we declare the class variable like this way. So if we go back to the previous slide, this constructor received two arguments. So this constructor will be called, and these arguments will be used to initialize the member variable month and day. So, so for date 1 object, month member variable will be set to 7, and day member variable will be set to 4. So similarly, month and day member variables of day 2 objects will be set to 5. So this is one way of calling the constructor, open and close brackets when you declare the class variable. The another way of calling constructor is using new keyword, as shown here. You can create object with new keyword like this one. As we already learned that using new keyword, we can dynamically allocate memory in heap regions. So as you can see here, this is a pointer variable. This one is not a pointer. So for this one, the object is created in heap regions because we use a new keyword. And for this one, the object is created in stack regions. You remember stack and heap, right? So we learned that in week 7. If you don't remember what stack and heap are, just review the week 7's material. Let me show you this concept, stack and heap, using example code. So this is an example code. We create two objects here inside of these main functions. Let's delete this one. So object 1, we are creating the object 1 using these open and close brackets. I said that because we pass two arguments here, the constructor which takes two arguments will be called automatically, which is this one. So because we are initializing the member variable month and day inside of this constructor body, the month will be set to this first argument value, and the day member variable will be set to the second argument value. So month will be 5 and day will be 10 here. And I said that we can also create object using a new keyword. And if we use a new keyword, we create objects in the heap regions. So that is the reason why we put pointer here. So I said that this object will be created in the stack, and this one will be created in the heap regions. So first, let me run this program. Okay, so let me run this program here. As you can see here, this is the output of the program. Because the constructor is called when we are creating this object one here, this print message here because of this one. And we also call the constructor here because, so that is the reason why this outputs here because of this. And the address of object 1 and object 2 is this one, because I print the address here. And this address region is a stack, and this address region is a heap. And because of while true here, this program does not terminate and it goes for forever because of this loop, infinitive loop here. So let me check whether let me check memory layout of this program first. So this is the process ID is this one. Okay, so this is the memory layout of this program. And if you look at here, there's a heap and there is a stack. And if you look at heap first, the just heap region is this one, starting with this 5817B00025819000. So this is the heap regions. And as you can see here, this address is inside of this range memory area. So this object is created in this memory region, which is a heap. And if you look at the stack here, let me make this font a little bit larger. So the stack's memory region starting from this FFAB3000 to FFAD4000. And as you can see here, the object 1's address is this one, which is inside of this memory region. So this object 1 is created in the stack, and this object 2 is created in the heap memory regions. So that's because we create object 2 using a new keyword, which will allocate memory from the heap regions. And if we create object like this way, it will use a memory regions of a stack. So that's the differences. Okay, so let's go back to the slide. So we just saw this example code, compare the stack and the heap memory layout. Okay, so we have discussed this line in previous slides. You might think that these 3 lines are equivalent to this 1 line because they both declare the objects of day of year class, and they both create date 1 and date 2 objects, and they initialize object with the same value, 74 for date 1 and 55 for date 2. So you might think these two, this one and this ones, are same, but they are actually different. The difference between these two is that This one, we are explicitly calling a constructor in the same way as we call ordinary member function using a dot operator. So this is how we usually call the ordinary member function using a dot operator. But on the other hand, we are calling the constructor here implicitly in this line. The constructor is implicitly called because we did not call it directly here. And compiler automatically call the constructor if we pass the argument within this open and close bracket when we declare the class variable. So the main difference is that the above one, the constructor is called explicitly using a dot operator, and the below one, the constructor is called implicitly. It is called automatically by the compiler. And this one is syntactically correct, but the above one is illegal. You cannot call the constructor explicitly like you do for the ordinary function using a dot operator. So this one is incorrect, illegal, syntactically not correct. This will lead to the compiler error. To call the constructor explicitly, you have to follow this form, this syntax. This creates anonymous objects, and by calling the constructor, which takes two int type of arguments. That constructor will use 7 and 4 arguments to initialize the anonymous objects and store that anonymous objects into date1 class variable. So using this form, you can explicitly call the constructor. But you must note that when you are calling the constructor explicitly like this, you are creating a new object. So here you create the object for date1, and here you are creating a new object for date1 class variable. So there are 3 different locations where you can initialize member variable: inside of the constructor body, and in the initialization sections. And you can also initialize non-static member variable like this when you are declaring them. So in this example, we are setting months and day in 3 different locations. One here, well, another one here. Then the question is that in which order the member variables are initialized. So let's run this source code and check it in the terminal. Okay, so this is the example code. As you can see here, there is a class definitions. Class name is a day of year, like the previous example. Let me make the font larger. And this class has a 2 member variable, months and day, and we initialize this member variable, months and day, like this one. And we also initialize this months and day member variable here inside of this initialization sections. And we also initialize the member variable months and day inside of this constructor body. So this is a constructor because its name is same as the class name, and it does not return any value. So this is a constructor which receives 2 arguments. So there is a 3 different locations where the member variables are initialized here, here, and here. And we declare the class variable object1 here. The class name is a day of year. So because we put 2 arguments here, this constructor will be called. So let's check in which order the member variables are initialized. One more thing, this output is a member function of this day of year class. This member function just prints the member variable month and day. Let me compile this program and see the output. Okay. So if I compile this program and run it, this program produces this output because we print the month and day here. Month is 5 because of this one, day is 10 because of this one. So if you look at the result of this one, here we initialize month and day to the value of 1. And here we initialize month and day using a value 2. And here we initialize the month and day using these 2 arguments, which is a 5 and 10, 5 and 10. And as you can see here, this program produced these outputs, 5 and 10. That means the value of month member variable is 5, and the value of day member variable is 10, which means that this one, this initialization statement was invoked at the last. So we can say that in which order this will be the 3rd order. And if I delete this one, if I compile again, if I run again, now the output is 2, 2. So we set the month and day member variable 2, 2 in initialization sections. So we can say that this is a 2nd order. And let me delete this one. And if I compile program again, now the month and day is 1, 1 because of here. So we can say that member variables initialized first here, and then here, and then here. So this order. Go back to the slides. So as we just check using the demo code, the member variables, the order of class member variable initializes, the first one is this one. The second one is an initialized section, and the third one is a constructor body. So 1, 2, 3. And so I said that the main purpose of the constructor is to initialize objects of the class. This doesn't mean that the constructor should have only initialized statements. As you can see from this example code, we initialized month and day member variable in the initialization sections. So the initialization of member variable is done here. And this doesn't mean that the constructor body needs to be empty. Inside of the constructor body, we can check whether the arguments are valid, like this one. By doing so, we can ensure that objects are initialized with correct values. This obviously will improve the reliability of the program. Let's run this demo code. We have a pause, validate. So this is a demo code for validating the argument. So like the previous example, we have a class definition here. The class name is a day of year. We have a constructor here, which takes 2 arguments. And this is the definition of the constructor. We initialize month and day member variable inside of these initialization sections. And inside of this constructor body, instead of initializing member variable, we just check the value of member variable, whether they are set to correct value. So here I check months should be greater than 1, and I check the month's value whether it is between 1 to 12. And also I check the day value, whether it is between 1 to 31. So if I run this program, months is 12 and 25 because we pass the value 12 and 25. And if I keep the months some 0 or some negative value, and if I compare again, now as you can see here is illegal month value because 0 is not allowed because of these conditional statements. If I like this one, you can validate the arguments passed to these constructors so that to make the program more reliable and make sure that objects are initialized with correct argument values. Okay, so let's go back to the slides again. So this is the demo code we just saw. We can also place the constructor in private sections. This is not common. This is not common because if the constructor is private, it cannot be called outside from the class. This means that you cannot create object using a private constructor. But sometimes this may be useful. Declaring private constructor, you can restrict certain ways of creating objects. For example, if you place the constructor that takes 2 double types of arguments in private sections, you can prevent programmers to create an object using 2 double types of value like this one. It prevents programmers from creating the objects of day of year class using a 2 double types of value if you put that constructor in the private sections. So let me show you this concept using a demo code. So I will talk about the constructor overload in the following slides, but these are all the constructor because its name is same as the class name and it does not return any types of values. And as you can see here, this one is also constructor, but we put the this constructor in the public sessions, and these 3 constructor in our private sections. The difference is that this constructor receives 2 type of values, and this constructor receives 1 int and 1 double, and this one receive double types of value for the first argument and int type of value for the second arguments. And this constructor receives 2 arguments, which both are types of double. So let's compile this program and see the output. Okay, so it compiles well. It does not produce any output because it just creates the objects. It compiles well because I passed the 2 type of values, which is this one. So this public constructor will be called. But if I change the value to 2 double type, like this one, now the argument, first argument, the second argument's types are double. And if I try to compile this program again, now compiler error occurs because I cannot call the private constructors. Because this is a 2 double types of arguments, this one will be invoked, but because of this constructor is private, compiler throws error message. Compiler will also throw a message if I change this one. Now, because the first argument is a type double and second argument is a type int, this constructor will be invoked, but because this one is also private, compiler will throw the error message. As expected, compilers are complaining about calling the private constructors. So if you put the constructor in a private sections, you cannot create objects using this constructor. By doing it, you like this one, you can restrict programmers to create an object in a certain way, like this one. But again, this is not normal, but it may be useful if you want to prevent, if you want to restrict some programmers to create objects in a certain way. So let's go back to the slide. Okay, so I just said that the constructor can be overloaded just like other member functions. We have already learned about function overloading. To quickly recall it, we learned that function overloading is a feature of programming language that allows many functions with same name but with different function signatures. And the function signature is made of function's name with the types of parameter list. So function signature consists of name and a parameter list. And return type is not included in the function signatures. So we can have a same name of 2 or more functions if their function signatures are different. So that's function overloading. I also said that function overloading is not possible in C. It's only possible in C++. And the constructor can also be overloaded as well, just like other member functions. By overloading constructor, we provide multiple ways for the programmers to create objects. This is the example code showing constructor overloading. So if you look at here, there is 3 constructor. Let me show you this example using a terminal in that way. Let's use the same code. Actually, I have a demo code for function overloading here. Okay, so This code is a little bit long, but nothing special. So this is a class definitions. Class name is day of year. So this one, 1, 2, 3 are the constructor, because its name is same as class name and it does not return any type. So they are a constructor, and we call this is a constructor overloading because it has the same name of 3 functions, but it has a different function signature because this parameter have 2 types of int. This one is 1, and this one does not have any parameter. So these 3 constructor or have a unique function signature. So this is syntactically correct. We can do this. One advantage of using this constructor overloading is that now you can create this object of this day of year class using a 3 different way. The first one is not using any argument, and second way is only using 1 argument. The third way is using 2 arguments. So like this way. Here you're creating the date 1 object using 2 arguments. This is possible because we have declared a constructor which receive 2 arguments, and we can also create the objects of day of year class using 1 argument, and this is also possible because we declare the constructor with 1 argument. And you can also create the object using 0 argument like this one. This one is also possible because there is a constructor which do not receive any arguments. So if I compile this program, it compiles well and it produces the output as expected because we pass 2 and 21 here, so it prints here. Because we pass 5 here, it prints once for 5, 1 for member variable day because day is 1 is a default value. And if we do not pass any arguments, the default value for month and day is 1, 1. So it prints 1, 1 here. So like if you use a function, if you use a constructor overloading, you allow programmers to create objects in multiple ways like this one. So let's go back to the slides. We saw this demo code. When you are creating objects using the constructor with no arguments, it is a little bit strange as we saw in the previous demo code. When you are calling ordinary function with no arguments, the syntax is this one: function name and empty brackets. So for example, if the function name is a test func, to call these functions, we use this form. If this function does not receive any arguments, parameters, we just put the empty brackets here when we call these functions. This is the usual. However, this changes for the constructors, as we learned that when we are declaring the class variable, the constructor is automatically invoked. So if you declare the date 1, the class variable like this, the constructor which do not receive any arguments will be automatically called. An object will be created using that constructor and stores the object into the date 1 variable. This is correct, but this one is not correct. You should not include the empty brackets. So this is a little bit strange because normally if we we put the empty brackets if we try to call the functions that do not take any arguments, but just for the constructor, we do not put the empty brackets. So remember not to use any brackets when you declare the class variables like this. And once the constructor invoked with no arguments. But when you are explicitly calls the constructor, you have to include the brackets like this one. We learned that this creates an anonymous object of day of year class. The anonymous object is an object that is not named by any variables. The anonymous object will be assigned to these date1 variables. So if you explicitly call this constructor like this, the constructors that do not take argument will be called for this one. So you may be confused when to use and not to use brackets because you use brackets here and you do not use brackets here. So you may be confused. Then why C++ compiler reject the second line? It's just making us confusing. Why it reject class variable declaration with empty brackets? The reason is that if you carefully look at the second line, even though you may means declaration of the class variable date, C++ compiler can also see this line as function declarations. The name of the function is date, and this function does not receive any arguments, and it returns the day of year class type of the objects. So this is a function declaration syntax. So if C++ allow the second lines of class variable declarations, compilers will be confused whether it is class variable declarations or function declarations. So that is the reason why empty brackets are not allowed in the class variable declarations. The compiler will just interpret it as this one. Compiler will just interpret this one as function declarations. So no constructor will be automatically called. So be careful about this one. The constructor that takes no argument is called a default constructor. The default constructor is automatically generated by compiler if there is no constructor in the class definitions. The auto-generated default constructor does not receive any arguments and it does not do anything. So it will generate, if we use a auto-generated default constructor, then it will generate an uninitialized object of the class type. But if there is at least one constructor in your class definitions, the compiler does not automatically generate default constructor. So as explained here, depending on the situations, compiler does and does not automatically generate default constructor. So you have to be careful that if you include one or more constructor, and if you do not explicitly declare the default constructor, you cannot declare the class variable with no argument. So this is not possible if there is no default constructor. So in order to declare the class variable with no argument like this one, there must be a default constructor in your class definition, whether it is automatically generated by compiler or whether you explicitly define it. Let's review this default constructor concept using a demo code. This one. Okay, so if we look at the code first. Okay, let me first explain the code. This one is a class definitions. As you can see here, there is no constructor inside of these class definitions. And because there is no constructor, the compiler will automatically generate the default constructor. And this is the member functions of output we declared here. So if I compile this program, and run it, it prints this once for this value and day for 1, because we call this output member function. In this output member function, it just prints the member variable months and day. And we create objects here. And because we did not pass any argument, the default constructor will be called automatically. The default constructor is the constructor that do not receive any arguments. So this default constructor will be used to initialize this object 1. And if you look at this class definition, there is no constructor because they are all commented out. So the compiler will automatically generate the default constructor for us. So this compiles well, even though we did not put any constructor because of the auto-generated default constructor, we could create an object like this way. But as you can see here, the value of months and day is not as expected, because auto-generated default compiler do not initialize the object. So here we can say that we create the object 1, uninitialized object 1 here. Because the member variable are not initialized, the garbage values are printed here. And if I put this one, this should lead to compiler error. Now, compilers throw error message because there is no constructor for receiving 2 arguments. So in this class definition, there is only one constructor, which is a default constructor that is automatically generated by the compiler, and that constructor do not receive any arguments. So this one leads to the compiler error. So to fix this compiler error, I need to create the constructor that receives 2 arguments. And because these are just function declaration, I need to put the constructor definitions here. And as you can see here, the member variable months and day are initialized with this first argument and the second argument. So now this line should be fine. But do you think this program compiles well? Because now we have these 2 with this constructor which receive 2 arguments. Do you think this compiles well? Let's check it. Nope. The compiler still complains about it, even though we create the two constructor which receive two arguments. Why is that? If you look at the compiler error, now compilers cannot find the constructor for creating these objects. So 35. This compiler error is saying that it cannot find the constructor which do not receive any arguments, which means it cannot find the default constructor. Why it cannot find the default constructor? Because we declare this constructor. I said in the slide that compiler only automatically generate the default constructor if there is no constructor in the class definitions. But now, because there is a constructor definitions here, the compiler do not automatically generate the default constructor. So to allow programmers to generate objects using a default constructor, you have to define default constructor by yourself. So to fix this compiler error, you have to explicitly define the default constructor like this one. This is a default constructor because it does not receive any arguments. And the default constructor just set the month and day value to 1, 1. Now this program should compile. Well, as you can see here, compiler do not complain anything. If I run it. Now, object 1, the member variable month and day for object 1 is 1, 1, because inside of this default constructor, we set them to 1. So that's about default constructor. Let's go back to the slides. So be careful if you define any constructor, compiler do not make the default constructor for you. So if you want to allow programmers to declare the class variable without any argument, you have to explicitly define the default constructor. Okay, there is another type of constructor, which is a copy constructor. Copy constructor is a constructor which initializes object using an object of the same class that has been created previously. As you can see from this example code, this one is a copy constructor. It has a single parameters like this one. The parameter type is a const class type. So the copy constructor receives object of the same class type. And using this object, it initializes new objects. The copy constructor is used 3 different cases. First, it is used when we initialize one object from another object of the same type. So if you look at this example code, we create new year objects. This object's type is a day of year class type using this 1, 1 argument. And now we are declaring another object's holiday of the same type of class, day of year, but we are assigning this previously generated object to this holiday objects. So by doing this, the copy constructor will be automatically invoked. So these holiday objects will be initialized using these uYear objects through copy constructor. So that's one situation when the copy constructor is called. The copy constructor is also called when we call function as call by value, and if we pass an object as function arguments. If you look at this example, this print day function receives objects of class type day of year. So here we create new year objects, which is a day of year class type, and we pass this object to this print day functions. And because this is a call by value passing method, the copy of these objects will be passed to these print day functions. And when copying the objects, the copy constructor will be automatically called. So this is the second situation when the copy constructor is called. And finally, the copy constructor will be used when the function returns a copy of the objects. That copy will be made by using a copy constructor. Okay, so let's look at the example code for this copy constructor. Okay, so there is a class definitions. CP is a class name. We have a one member variable, student number, and two constructor, because it's same name of the class name, and one member variable, one member functions, get student number, which it just returns the student number. And this is a normal constructor which takes one argument and set the student number member variable using this argument. And this is a copy constructor because it receives the objects of the same class type. So this is a copy constructor. And if we look at the main functions, we create one object, obj1, of CP class type using a one argument. So this one compiler will automatically call this constructor because this constructor receives one argument. And using this argument 52, the compiler will initialize this student number to 52. And here the copy constructor will be invoked automatically because we are creating object 2 here by using previously created object 1. So copy constructor will be invoked in this statement. And this one just prints the member variable student number for object 1, and this one prints the member variable student number for object 2. So let's compile this program and see the output. Okay, so this is the output of this program. First, it prints in normal constructor. It's from here. This constructor calls here, so that is the reason why this program prints this one, and then it prints this one, copy constructor, which is this one. This copy constructor is called here. So that's the reason why this program prints this output. And because 52 is used to initialize the object 1, so student number member variable for object 1 is 52. And if you look at this copy constructor, we use this object student number to set the current student number member variable. And because this object is obj1, and because obj1 student number is 52, 52 is also set to object 2. So that is the reason why the student number for object 2 is 52 as well. So that's the copy constructor. So let's go back to the slide. If you do not explicitly define copy constructor in your class definitions, the compiler automatically generates the default copy constructor. The default copy constructor works fine. You can use it if your class does not have any pointer member variables. But if your class consists of pointer member variables, you have to think twice. Because the default copy constructor perform shallow copy. There are two types of copy, shallow copy and deep copy. The shallow copy copies the pointer addresses, not the actual value that the pointer points to. And on the other hand, the deep copy copies the actual value that the pointer points to. So if you want to copy the actual value that the pointer points to, you cannot use a default copy constructor because default copy constructor works as shallow copy. For that, you have to define your own copy constructor and perform the deep copy. This diagram shows the differences between shallow copy and the deep copy. As shown in this diagram, there is object bag1, and it has a 4 pointer as a member variable, and they are pointing to these memory locations. And if you create bag2 objects by copying bag1 objects, if you perform shallow copy, the pointer in the two objects, bag1 and bag2, will share the same memory. So like this example. So first, pointer member variable for bag1 and pointer member variable, first pointer member variable for bag2 will share the same memory locations. And same for second and third and fourth one. They will share the memory locations. But if you perform the deep copy, pointers in bag1 objects and bag2 objects do not share the memory. So if you look at this example, bag2, first pointer of bag2 points now different memory locations. First pointer is pointing to here, but bag2's first pointer now points to different memory locations. So using deep copy, bag1 and bag2 are completely separated, and they are independent to each other. But for shallow copy, because they share the same memory locations, if you change the value through this pointer member variable from bag1, it also affects the bag2 as well. So that's the difference between shallow copy and deep copy. Okay, so let's compare the deep copy and shallow copy using a demo code. Okay, so here we also have a class named CP. Now this class has a two member variable. One is an int type member variable, student number, and another one is a character pointer, which is a instructor. And we have one constructor which receives two arguments. And using this argument, we use first argument to set the student number, and we use the second argument to set the instructor member variable, like this one. And we also have a copy constructor. This one performs shallow copy. It just share the memory if the object consists of the pointer. And this member variable just returns the student member variables, and this member function just returns the instructor member variable. So using this one, we create one object of CP class type using a constructor that receives two arguments. So 52 and HSJ. This constructor will be called. So student number will be set to 52 and instructor member variable will be set to HSJ. And here the copy constructor calls. And because this copy constructor performs shallow copy, even though the first member variable do not share the memory location because it is not pointer, the second member variable for the object 1 and object 2 will share the same memory location because it performed the shallow copy here. So because of that, this member function just prints the second member variable instructions. So here it will both print HSJ because for object 1, we initialize the second member variable, the instructor, with HSJ. And for object 2, by using a copy constructor, we set the object 2's instructor member variable with HSJ as well. And this change INS member variable is this one. It just changes the member variable instructor to the given argument value. So here object 1's instructor member variable will be changed to AAA from HSJ because of this one. So if I call this one, this should print AAA because I changed the member variable instructor AAA here. But what about this one? The object 2's instructor member variable was HSJ. Do you think this line still print HSJ? Let's compile this program and see the output. Okay, so this is the output of the program. Here, normal constructor is called, so this prints here. And copy constructor calls here, so this one comes here. And because HSJ is set to instructor member variable for object 1 and object 2, here HSJ is printed here. And I changed the instructor member variable using these member functions to AAA. So object 1's instructor member variable is now AAA. But as you can see here, object 2's instructor member variable is also AAA, even though I only changed the object 1's member variable instructor. Object 2's member variable instructor is also changed as well. This is because we performed the shallow copy. I said that shallow copy because of this was shallow copy. The pointer member variable, which is an instructor for object 2 and object 1, will share the same memory location. So because they share the same memory location, even though I changed the object 1's instructor, object 2's member variable instructor is also affected as well. So if you want to prevent this one, you have to perform deep copy. So let's change this shallow copy to deep copy. Now this copy constructor performs the deep copy. Previously, the same memory locations are shared like this one, but now the instructor for the new objects, we create the new memory, we allocate new memory for the instructor member variable for the new objects and copies the value of the previous objects instructor member variable values to this newly allocated memory location. So this performs the deep copy. So if I now compile again and run it, as you can see here, previously, even though I changed it object 1, it affects the object 2 as well, but now it does not affect the object 2's instructor. It only affects the object 1's instructor. So that's the differences between shallow copy and deep copy. You can freely use shallow copy if your class does not have pointers like this instructor member variable. It just works fine for primitive member type like int. But if your class consists of pointers, then you must use deep copy. Otherwise, this unexpected result will be occurred. Okay, let's go back to the slides. Okay, so we talk about this one using a demo code. Okay, so in C++ 11, a new feature, the Constructor Delegation, is introduced. Using these features, one constructor can invoke another constructor. If you look at this example, the default constructor calls another constructor which takes 2 int value. So like this notation, you put the colon and calls another constructor. Then this constructor will be invoked because this is the constructor which takes 2 int type of arguments. And then x is a member variable and y is also member variable. X will be set to 99 because this one is 99, and y member variable will be also set to 99 because this is 99, y here is 99, and 99 is here. So this is constructor delegators, not difficult concepts. You can invoke another constructor. That's constructor delegators. Then this is the notations. Okay, so far we learned constructor where the object is initialized. Note that if we dynamically allocate memory, it will not be freed until we deallocate it. So if there are pointers in member variables in your class, we must deallocate them when we finish using the objects. So how can we do that? Similar to constructor, there is a special type of member functions called Destructor. Destructor is just opposite of constructor. Destructor is a member functions which is called automatically just before the object is destroyed. So Destructor is the last function that is going to be called before the object is destroyed. Therefore, we put the allocation statement inside of this Destructor. So this is the Destructor. The Destructor does not have parameters, and it has same name as class, like a constructor, but preceded by a tilde. And only one Destructor is allowed in the class definitions, and same as constructor, if we do not define Destructor, default Destructor will be automatically generated by the C++ compiler. But that default versions of the Destructor do not deallocate the dynamically allocate memories. So if your class has pointer member variables, you should explicitly write a Destructor and release them. You must not rely on the default Destructor, otherwise memory leaks occurs. So let's quickly look at the example code for the Destructor. We have a class definition here. This is a Destructor. These two are constructor. The difference is that it starts with a tilde. And Destructor, this is the definition of Destructor. You put the class name and the scope resolution operator, and then put the Destructor function name. Same as the constructor, but start with this tilde. And this Destructor is called just before the object is destroyed. So we create the objects here. This Destructor will be called when this int main function finishes. So let's see whether this Destructor is called automatically by the compiler. As you can see here, object is created. It prints here, and constructing is printed here from the constructor, and destructing is printed here inside of this Destructor. So constructor is called here when we declare the class variable. But as you can see here, there is no statement of calling this Destructor. It is automatically called by the compiler when this int main function is finishes. So this is the Destructor. So, okay. Let's go back to the slides. Okay, so in summary, in these sessions, we learned about constructor, which is a special types of member functions for initializing objects. And we also learned about default constructor. Default constructor do not receive any arguments. And if there is no constructor in the class definitions, the compiler will automatically generate the default constructor. But you have to note that that default constructor do not do anything. So that will lead to the uninitialized objects. And there is two types of copy, shallow copy and deep copy. You have to careful about this if your class consists of pointer variables. And we also talk about that constructor can be overloaded just like other functions. If we overload the constructor, we provide the programmers to multiple ways of declaring the class variables. And we also talk about the destructor. Destructor is the last function that is going to be called before the object is destroyed. Okay, so that's it for these sessions. See you in the following sessions.